Hey guys, welcome. This is 12.5 again. This goes over average value. So what we did last time was we did the evaluation theorem of the fundamental theorem of calculus. So we took an integral on an interval, and when we found the antiderivative, we computed the antiderivative on the interval. So we plugged in a and b to that integral into that antiderivative as well. So what we're looking at now is the average value of a continuous function on some closed interval AB. So what this is going to be is evaluation theorem again. And remember that with the evaluation theorem, it helps you find the area underneath the curve. So what we're going to do is find the average value of the area underneath the curve. And that formula is given as 1 over b minus a times the integral from a to b of f of x dx, which becomes 1 over b minus a of the antiderivative evaluated on the interval a to b, which becomes 1 over b minus a of, or times, f of b minus f of a. So we're doing everything we did in the last section, except the only addition we are adding is this 1 over b minus a. That's the only addition that we're adding. Okay. Perfect. So, same formulas apply for antiderivatives. So you see we still have the power rule. We still have the integral of e to the x dx. But we have one new formula which we're going to have to use today. And that formula is number 3. And we'll use it when we get to the problem. You'll know which problem it is. So this is our new formula. The integral of e to the ax dx is equal to 1 over a times e to the ax plus c. So that's the only new integral formula. That's it. Everything else is the same. Okay. So let's get started. Example 1. Find the average value of the given functions on the given interval and graph the function and its average value over the indicated interval. Okay, so here's how we're going to set this up. There you go, zoom in a bit. So I'm going to rewrite the average value formula above, just to get us familiar with it. So the average value, the average value is given by 1 over b minus a of the integral from a to b of f of x dx. So that is our average value integral. So that's what we're going to use. Okay, over there I wrote average value. Okay, so now let's go ahead and set this up, but also let's label everything we have. So the interval 0 to 5, 0 is a, 5 is b. Okay, so now when I set this integral up, we're going to have, get some more room here, there we go. We're going to get 1 over 5 minus 0 times the integral of 0 to 5 of 2x plus 7 dx. 2x plus 7 dx. Now, let's go ahead and clean this up. This will become 1/5 times, and let's go ahead and find the antiderivative already. So I'm going to put a bracket here, and let's start with 2x. Let's start with the antiderivative of 2x. So the 2 remains in front, and we apply power rule to x. So that becomes x squared over 2. Plus, now we want the antiderivative of 7. So that would be 7x. Close that. And we will be evaluating this antiderivative from 0 to 5, just like all the other ones. So one big cleanup, you get 1/5 times x squared, my 2's cancel, plus 7x, still evaluated from 0 to 5. Okay, almost there. Now I'm going to distribute that 1/5. And you get 1/5 x squared plus 7/5 x, still evaluated from 0 to 5. We are now ready to type this in our calculator. Okay, so remember, I'm going to show the long way first. So if you have the table feature in your calculator, right, you hit table. Well, I'm on the fancy smancy calculator, but it's the same thing. You hit table, and I do add or edit function. So we say add. I'll clear this one out. And I have 1/5 x squared. Well, 1/5 is what, 0.2? So I can write this as 0.2 x squared plus 7/5. What's 7/5? 1.4. 1.4 x. 0.2 x squared plus 1.4 x. Enter. No g of x. Enter. Table setup, make sure it's on ask x or x equals. Enter, enter. And now I'll delete the values that are here. And we only want to type in 2 values. 5, which gives me 12. And I'll write that there. 12 minus, if I type in 0, we get 0. So this means that 12 is the average value. There you go. Now, again, long way for everything. So that was on this calculator. Let's go to the graphing calculator, because let's say you don't have that integral function. So again, I'll do it again. 1/5, so 0.2 x squared plus 1.4 x. Enter, second window. And my settings are still the same from the last time. It's always on ask. Then I go second, graph. Delete the values that are there and type in the 2 numbers that we need. 5, which gives me 12, 0, which gives me 0. And 12 minus 0 gives me 12, which is the average value. Okay, now let's do it the easy way. All right. So if you have the integral button, your life's about to get really easy. I mean, you still want to show work, but your life's going to get really easy so you can check your work. So the first thing we're going to start with is that fraction of 1/5. So I can go math, where is it? N over D, it's on number. Number, N over D. I'm going to say 1/5. And if you look at what I'm typing in, I am typing in, where is it? If you look on the right side of your screen, I am typing in this part. That's what I'm typing in the calculator. So 1/5, then I go math, go down to FN integrate, we're doing this from 0 to 5. And this is going to be the function 2x plus 7 with respect to x. There it is. Hit enter, and my goodness, 12 automatically. Crazy, I know, right? And you could have even done it with the 0.2 in front, because that's what 1/5 is, 0.2. And we still get the same answer. Okay, now showing it on the smaller fancy calculator, I will do the same. I'll say fraction 1/5, second integral 0 to 5 of 2x plus 7. And hit enter. 12. It's just magical, and you're welcome. Okay, so 12 is our average value. Now our goal is to graph, our goal is to graph, what's it say? Graph the function and its average value over the indicated interval. Okay, so I'm going to graph this. So the first thing I'm going to do, so I guess we can make this a step. I'll call this step 2. Graph g of x and the average value. Graph g of x and the average value. Okay, so we're going to graph g of x, and g of x is given as 2x plus 7. Okay, well, what's easy about this is that it's giving us the x values to choose, because the interval it's giving us is 0 to 5. So g of x equals 2x plus 7. So I'll make a small xy chart. And I'll pick the numbers 0 to 5. Zero, 1, 2, 3, 4, 5. And I'm going to plug all of those values into g of x. So I'm plugging all of these into g of x. So if I plug in 0, I get 7. If I plug in 1, I get 9. Plug in 2, I get 11. Plug in 3, I get 13. See a pattern, 13, 15, 17. Okay, so that means that next, let's go ahead and graph it. So keep scrolling over, sorry, messed that up. And I'm gonna make intervals from 0 to 5. So here's 0, 1, 2, 3, 4, 5. And then we start at 7, 9, 11, 13, 15, 17. So I'll just make my y values that. 7, 9, 11, 13, 15, 17. Why not? Can I get closer and label these? Probably. All right. So 7, 9, 11, 13, 15, 17. Okay, and graph. So for my XY chart on the left, we're at 0, 7. I'll make this point a little bigger. How's that? 0, 7. And then we're at 1, 9, 2, 13, 3, 15, or 3, 13, why did I skip a number? 0, 7, 1, 9, 2, 11. Oh yeah, I skipped one. Oh well, it's in there somewhere. All right. 2's 11. I'll fix it. 2's at 11. 3's at 13. 4's at 15. 5's at 17. So that's what our graph looks like. And I'll put the points back on there. There you go. There's our graph. Okay. And now all this wants is the average value. Remember, our average value was 12. So this means that, oh, come on, computer. We're going to graph the line y equals 12. So that's our average value. So 12 is right between 11 and 13. So here's the average value. There it is. Average value of 12. All right. And it's also a horizontal line, so it's y equals 12. And this was our g of x equals 2x plus 7. And that's it. That's all I wanted. That's all. That's what step 2 wants. It just says graph it with the average value. Okay. So what it's saying is that when this function 2x plus 7 is on the interval 0 to 5, the average value between all the x and y values is going to be 12. That's it. Okay. Or the average value between all the y values is going to be 12. Okay. That's it. Plus 9 plus 11 plus 13. Yep. Okay. Cool. All right. Let's do it again. So, number 2. Same setup. Average value. So zoom in again. That should be good enough. And -1 will be A, 2 will be B. All right. So here's our setup. So we're going to have average value. And we get 1 over B, which is 2, minus A, which is -1, times the integral from -1 to 2 of x minus 3x squared dx. Now, let's clean it up. This now becomes 1 over, remember minus minus makes plus. So it becomes 1 over 3 times the integral from -1 to 2 of x minus 3x squared dx. Okay, now let's find the antiderivative, which means this 1/3 is going to wait outside. Bracket. And let's find the antiderivative of x. That's our first one. So the antiderivative of x, we've done it so many times, is x squared over 2. Minus, now we want the antiderivative of 3x squared. The 3 will wait outside, and you will power rule x squared, which becomes x cubed over 3. And we are evaluating this from -1 to 2. Okay, so you get, whoops, wrong color. Clean this up. You get 1/3 times, and I'm going to rewrite x squared over 2 as 1/2 x squared minus, and on 3 times x cubed over 3, your 3's will cancel. So you're just left with x cubed. Evaluated from -1 to 2. Okay. Last step, distribute that 1/3. And 1/3 times 1/2 is 1/6 x squared minus 1/3 x cubed from -1 to 2. We are now ready to calculate this. Okay. And for your pleasure, I'll do it one more time. I'm going to show you the table feature. Okay. So before we start, though, 1/6 is a run-on decimal number, and 1/3 is a run-on decimal number. So if you do not have the integral functions, when you use your table, what we're going to do is fraction 1/6 x squared minus fraction 1/3 x cubed. There it is. 1/6 x squared minus 1/3 x cubed. Okay. Hit enter, 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 and delete the numbers that are there. Delete, delete. And let's type in the first number we need, which is 2, because it's the upper. You get -2. So I get -2 minus, and then type in -1. And you get 1/2, or make it 0.5. So -0.5. And -2 minus 0.5, -2.5. Okay. So let me go back to the table, or actually I'll go to the graphing calculator and show it again. I'll go to y equals. Let's say you don't have the fraction button at all. Then here's what you'll type in. Parentheses, 1 divide 6, close parentheses, x squared, minus parentheses, 1 divide 3, x, where are you, cubed. Just like that. 1/6 x squared minus 1/3 x cubed. Enter. All your settings should be the same still, so all you have to do is hit second and graph. Delete the numbers that are there, and let's type in 2. You'll get -2. Let's type in -1. You'll get 0.5. -2 minus 0.5, -2.5. Now, for the people who are special and have that special function, let's go back. And then I'm going to say, I'll start with the fraction first, actually. So math, number, fraction, 1. What's on the outside? Okay, and remember, if you're checking your work for the integral, again, this is the part you're typing in your calculator. So whatever I box in red is what you're typing in your calculator. Okay, so 1/3 times the integral from -1 to 2 of x minus 3 x squared dx. 1/3 times the integral of -1 to 2 of x minus 3x squared dx, and enter. -2.5. Life is good. Okay, and you would do the same inputs on this calculator. So if you have that, same thing. Okay. Okay, so our job now is to actually graph this. So let's move over to the right. How much room did I have? That's perfect. Okay, so make another step 2, graph. This one's f of x. So step 2. Graph f of x and the average value. Graph f of x and the average value. So our f of x is the function x minus 3x squared. So x minus 3x squared. Okay, and again, they're giving us the numbers to plug in. So when I make my XY chart, it says our interval is from -1 to 2. So I'm going to go -1, 0, 1, 2. Okay, and I want to get these values faster, so I'll use the table feature for this, and I'll type in x minus 3x squared, enter, 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 delete the numbers that are there, and type in what I need. So -1 gives me -4. 0 should give me 0. 1 is going to give me -2. And 2 is going to give me -10. Okay. So there's that. Now I'll make my graph. All right. So there's my graph. And how much can I zoom in on this? On here. So I'm going from -1 to 2. So this will be -1, 0, 1, 2. From -1 to 2. And my y values, let's see, it's -4, 0, -2, -10. Oh, so I'm going negative. And I can go by 2s then. So I have -2, -4, -6, -8, -10. So -2, -4, -6, -8, -10. Okay, and let's plot. All right, -1, -4, that's right there. 0, 0, right there at 0, 0. Maybe I'll use a different color. How's that? -1, -4, 0, 0, 1 and -2, 2 and negative 10. There it is. I see that that negative got erased. Okay, now let's connect. All right. What's a good color? Green, sure. So connect. And connect. I gotta show my points again. Boo. 0, 0. There we go. There it is. Okay. So there's that. And then my average value is what? Negative 2.5, right? It was negative 2.5. So we're just going to put negative 2.5 right here. But not that far. So from right there. There it is. So that's my average value of y equals negative 2.5. And this is my, whoop, too big. And this is f of x equals x minus 3x squared. That's it. What do I have? 4 plus 2 plus 10 plus 0 divided 4. Oh, we could do more. More y values. Okay, you get negative 2.5. Okay, so there's the average value. Okay, done. Let's do more. Okay. Okay, next one. You have the cube root of x on 1 to 8. So again, label everything. This is going to be A and B. 1 is A, 8 is B. Okay, and then our average value is going to be given by 1 over B minus A, so 8 minus 1, times the integral from 1 to 8. And now the cube root of x is going to have to be rewritten as x to the 1/3 dx. X to the 1/3 dx. Okay, perfect. All right, clean up, and we get 1/8 times the integral from 1 to 8 of x to the 1/3 dx. We are now ready for the antiderivative. Okay, so this means that 1/8 stays out. And you're going to get x to the 1/3. So you use power rule on this. Since it's a fraction, I'll help you out, right? You get x to the 1/3 plus 1 over 1/3 plus 1. And we are evaluating this from, too much. We are evaluating this from 1 to 8. From 1 to 8. Okay, well, if you don't know how to use your calculators, you sure can learn now. Watch this. I can even type it in without any special features. 1 divide 3 plus 1. Watch what's going to happen. 1.333 or 4/3, because that's the fraction we're going to get. Calculators are amazing, right? Or even if you add the fraction button, watch this. 1/3 plus 1. Whoa, 4/3. So we get 1/8 times x to the 4/3 over 4/3. Still evaluated from 1 to 8. Still evaluated from 1 to 8. And remember what we do with that fraction down there? We flip it over, right? We flip that 4/3 over. So I get 1/8 times 3x to the 4/3 over 4. Okay. Still evaluating from 1 to 8. And now one final cleanup. Go ahead and multiply that 1/8 in there. So you multiply and you'll get 3/32 x to the 4/3 from 1 to 8. Okay, and let's do it. All right, so let's say you're using your table. I'll show it again, why not? It's not long. So 3/32, 3/32, x to the fraction 4/3. 3/32 x to the 4/3. Enter, 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 enter. Type in 8. Delete everything that's there if you need to. Type in 8, and I get 3/2. 3/2 or 1.5. So this becomes 1.5 minus, if I type in 1, you get 3/32, which is 0.09375. Now subtract those two values. 1.5 minus 0.09375. Okay. And I'll do it to 2 decimal places, 1.41. There's our average value. Now again, shortcut. You'll type this part in your calculator. Okay, let's try it. Hope we got it right, guys. So, fraction 1/8. Second integral 1 to 8. of the cube root of x. So I have it as x to the 1/3. So x raised to the fraction of 1/3. 1.406 or 1.41. Boom, 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 boom. Perfect. Okay. Now we graph. So we'll graph f of x and the average value. Oop, too far. Okay, let's graph f of x and the average value. Okay, what was f of x? The cube root of x, right? So f of x is the cube root of x. Okay, let's go, computer. Catch up. You were doing great earlier. Now you're lagging. Okay. So graph f of x and the average value. We're given f of x equals the cube root of x, and we're already given the interval of 1 to 8. So again, we make our sign chart. Well, not sign chart, XY chart. Table. Okay. So x and y. And we're given 1 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Why not? And I'll use my table again to make this easier. Oof. So actually, since we're given 1 to 8, we don't need that many numbers. Let me see. Because since we're taking the cube root, I only want numbers I can take the cube root of. This will make life a lot easier. Trust me. So we'll do 1. The cube root of 1 is 1. Won't do 2, won't do 3, won't do 4, won't do 5. All right, we'll just do 1 and 8. Because the cube root of 1 is 1. The cube root of 8 is 2. That's it. That's all we need. Okay. And then we graph. And this means that this will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So 1 to 8. And the only y values we need are 1 and 2. So here's 1, here's 2. Okay. So let's plot our points. 1, 1, 8, 2. Right there. So what our graph looks like is this little curve here. It's a good color. That one still. Cube root goes like this and like that. So more curvy though. Like that. There you go. Little curvier. There we go. Okay. And I'll put my points down again just to show 1, 1, 2, 8. Okay. And then we want to graph our average value. What's our average value? It's 1.41. So I'll just put that right about half. And there it is. There's the average value. Oh, but we started at 1. So here, it has to start here. There we go. Because it has to be on the same interval. So there's the average value. And of course, I'll label it for you. That is f of x equals the cube root of x. And that is our average value of y equals 1.41. All right, cool. All right, that's it for those ones. I don't think we have to graph anymore. Thank goodness, right? Okay. So next, number 4. Given the demand function, find the average price in dollars over the demand interval 500 to 900 of P equals dx equal 3,000 over x. Okay, so this one's gonna be set up like the last ones. We just don't have to graph, which is perfect. Okay. So we want to find the average price. So again, I'll just say average value. And our interval is 500 to 900. So 500 will be A, 900 will be B. Okay, so we set up as 1 over 500, not 500, 900. 900 minus 500 times the integral of, from 500 to 900 of 3,000 over x dx. Okay, clean up. And you'll get 1 over 400 times the integral from 500 to 900 times 3,000 over x dx. Okay, so this problem's in my math lab. So what we're gonna do here, because in my math lab it says set up the integral. So what we're gonna do here is take this 1 over 400 and multiply it by the 3,000 over x. So that's what we're gonna do here. So if I multiply that in, I get the integral from 500 to 900 of 3,000 over 400x dx. Now let's do one simple cleanup. What's 3,000 over 400? Let's see. 3,000 over 400. 7.5, right? So I think that's what it wants. So this becomes, so this is the first part of the answer in my math lab. It's going to want the integral from 500 to 900 of 7.5 over x dx. This part is my math lab answer, right? That's for my math lab when you see this problem. Okay. Well, you're now ready for the antiderivative. And remember, since this is 7.5 over x, right? Well, this is going to copy that one formula. This is going to copy the integral of 1 over x dx becomes the natural log of the absolute value of x. So that's what we're going to use for this one, okay? Which means that, let me get rid of that, which means we can continue. And this will become 7, let me get closer. This becomes 7.5 times the natural log of the absolute value of x, evaluated, what's that too big? Evaluated from 500 to 900. Okay. Come on, computer. You did great earlier. There we go. Okay. So let's type in your calculator, table, clear, 7.5 natural log x. You don't have to worry about putting absolute value, just put x. Enter, 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 enter. Type in 900. And I get to 2 decimal places, 51.02. So I'll write that down. 51.02 minus, type in 500, 46.61. And then subtract those two. 51.02 minus 46.61 gives me 4.41. Okay, and then for my special calculator people, well, let's type it in. We're going to type in the green box that I have right there. From 500 to 900 of fraction 7.5 over x. 4.41. Bum, 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 bum. There you go. That's it. That's our average value. No need to graph this one. Thank goodness. Okay, perfect. It looks like average valve, not value. Oh, whatever. You get it. Okay, on to number 5. Price supply. Given the price supply function, P equals S of X equals 8 times e to the 0.05x minus 1, find the average price in dollars over the supply interval 40 to 50. Okay, remember that special integral formula I talked about? Well, we're going to use it here. So we are going to use number 3 for this one. So I'm going to write number 3 down, and then I'll scroll back to the problem. So by rule 3, we're going to use the integral from e to the ax, which is 1 over a times e to the ax, and then plus c. No constants of integration, though, because remember, when we evaluate, we have no constants of integration. Okay, so now we can come back to the problem. There it is. See, I wrote it already. Okay, so let's go ahead and set up the integral. There's 40 and 50, so that means 40 will be A, 50 will be B. So here's our setup. All right. So again, I'll write it. Average value, there you go. There's a U for you this time. Is going to be 1 over 50 minus 40 times the integral from 40 to 50 of 8 times e to the 0.05x minus 1 dx. Get this on the screen. There we go. Okay, we have some cleaning up to do. So this becomes 1 over 10 times the integral from 40 to 50 of 8 times e to the 0.5x minus 1 dx. Okay, the next thing I'm going to do here is I'm going to pull that 8 out. I do not need that 8 in there. So this 8 is coming outside because 8 times 1/10 is 8/10. So that's where that 8 is going. Okay. So we'll get 8/10 times the integral from 40 to 50 of e to the 0.05x minus 1 dx. Okay, we are now ready for the antiderivative. Well, first of all, 8/10 becomes what? 0.8, right? 8/10 becomes 0.8, so we'll make this 0.8. 0.8 times, and now we are going to use that new special integral formula on e to the 0.05x. All right, e to the 0.05x. So the integral is 1 over a times e to the ax. A represents the number in front of that x. So our a value here is 0.05, which means the antiderivative is going to be 1 over 0.05 times e to the same exact thing, 0.05x. Not bad, huh? That's it. That's what that became. Then minus, well, what's the antiderivative of 1 with respect to x? That's just x. And then we will be evaluating this from 40 to 50. Evaluate from 40 to 50. Okay, so some cleanup. Go ahead and distribute the 0.8 to both terms, right? Distribute the 0.8 to both terms. And for the first one, I'll do this. When you distribute that 0.8, it's 0.8 over 0.05. That gives me 16. So this becomes 16 e to the 0.05x minus 0.8x from 40 to 50. We are now ready to calculate. So go to my table, enter, enter, enter. Clear, I have 16 e to the 0.05x minus 0.8x. Enter, 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 enter. And I type in 50. and to 2 decimal places, 154.92 minus, type in 40, 86.22. Okay. And oh, you guys aren't seeing that. There you go. Okay. And then this average value, we have 154.92 minus 86.22, 68.7. Now let's double check our work. We are going to say which part do I type in? I am typing into my calculator. I'm typing in this part. This is the part I'm typing in. Okay, here you go. Well, 8/10 is 0.8, so 0.8 times the integral from 40 to 50 of e to the 0.05x minus 1. There it is. 0.8 from 40 to 50 of e to the 0.05x minus 1 dx. Enter, cross fingers. 68.69. Ooh, so we are off by a couple change, which means it's a rounding error on probably my part. So this is the actual true answer here. So I could go back and check my table, and let's see. So I had 151.9199 of all those, so 92, I did that. And could this been 8.6.23? Maybe, let's see. So 154.2.92 minus 86.23, 6.69. So I should have rounded that 2 up. So that's what I'll do. So this should have been a 3. And if we check our work, this becomes 68.69, just like I have it there. Possibly even if you rounded, that one that could be 68, oops, 68.70. But I'm thinking the box one's better. Okay, there it is. Okay, so that's how you handle this. All right, no, that doesn't seem too crazy, especially if you can type it in your calculator, right? Okay. Where is it? Take a quick break, pause. Okay, so here we have average cost. The total cost in dollars of printing X dictionaries is C of X equals 20,000 plus 10X. Find the average cost per unit if 1,000 dictionaries are produced. Remember, average cost, this is in 1324, right, is given by C bar of X, which is C of X over X. So all you have to do is take the cost function given, put it over X, and plug in 1,000. So that's what we're going to do for step A. Average costs. Okay. So A, we're looking for average cost. And average cost is given by C bar of X, which puts the cost function of 20,000 plus 10X over X. That's it. Now all we have to do is plug in 1,000. So C bar of 1,000 is equal to 20,000 plus 10 times 1,000 over 1,000. Okay, so all we have to do now is type that in your calculator, just like I wrote it. So fraction button, 20,000 plus 10 times 1,000 over 1,000. We get $30. This is average cost. Okay. So this is the average cost per unit, right? So it's like $30 per dictionary. All right. Okay. So then B. We want to find average value. Value with the U and not a V. Okay. So we're given the interval 0 to 1,000. So this is on the interval 0 to 1,000. This is my A. That's my B. All right, let's set it up. So make this better. What are we looking at? There we go. Okay. So we have 1 over 1,000 minus 0. So 1 over B minus A times the integral from 0 to 1,000 of the cost function. What's our cost function? 20,000 plus 10x dx. Okay, excellent. So now let's clean it up. And I'll get 1 over 1,000 times the integral of, oh wait, not of, but the integral on 0 to 1,000 of 20,000 plus 10x. 20,000 plus 10x dx. We are now ready for the antiderivative. So I'll keep 1 over 1,000 on the outside. And let's do the antiderivative. What is the antiderivative of 20,000? That's 20,000 x. Plus, what's the antiderivative of 10x? The 10 stays outside. You power rule the x. You get x squared over 2. Close bracket and evaluate from 0 to 1,000. Okay, clean up. 1 over 1,000 times 20,000x plus 10 times x squared over 2, that's just 5x squared. Still evaluated from 0 to 1,000. Okay, now take this 1,000 and distribute it to 20,005. And for the first one, it's 20,000 over 1,000, which is 20. So you'll get 20x plus 5 over 1,000, 0.005 x squared. From 0 to 1,000. Okay, we are now ready to calculate. That means we're almost home. So, here's what we're typing in our calculator. Table, enter, clear. 20x plus 0.005 x squared. Enter, 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 and type in 1,000, and we get 25,000 minus, and then if I type in 0, guess what I'm going to get? 0. So we get 25,000 as the average value. Okay. Perfect. Oh yeah, sorry. If you want to check this with the quick mode, what do I have? 1 over 1,000. So which part am I typing in the calculator? I am typing this part in the calculator. So fraction 1 over 1,000, integral from 0 to 1,000 of 20,000 plus 10x dx. Boom, 25,000, right on the money. Yeehaw, huh? Okay, cool. So the C says interprets the results from A and B. Okay. So I can just now maximize this screen. Boom, look at that. Okay. That'll work. So for C, I'll put that right here. C is interpret. And what we know is that the average cost is the price per book, right? So 30 bucks is the price per book. Is average price or cost per book, right? I'll put cost, not price. Average cost per book. And then the 25 large is the average cost for producing 1,000 dictionaries. Boom. And that is average value. Yee-haw, guys. That's how you work your calculator. That's how you do everything. I've showed you everything you can do with the calculator now. Well, for this class, right? Okay. Excellent. Well, that is it.